Hello, this video is about using the percentage points table for the normal distribution. So in the formula book, there is this table, the percentage points table, which shows probabilities that Z will exceed certain numbers. Okay, now once upon a time, before we could actually use our calculators to do any of the normal distribution, we used a separate table which had Z values going up in 2 decimal place numbers and giving probabilities to 4 decimal places, whereas this table was for the other way around. It gave specific probabilities and then Z values were given to 4 decimal places. So for example, the probability that Z is greater than, say, 0.3 is 0.5244. The probability that Z is greater than 0.005 is 2.758, and so on. Note that this table is for a Z distribution, which is defined as having a mean of 0 and a standard deviation of 1. So let's say that we were asked to find the values of U and V, such that the probability that Z is less than U is 0.4 and the probability that Z is greater than V is 2.5%. So starting with the first one, the probability that Z is less than U gives 0.4. From the table we can see that the value of Z corresponding to a probability of 0.4 is 0.2533. But notice, if you think about the area under the graph, the area is 1. So the probability of being less than U, if that's 0.4, that means we're on the left-hand side of the graph, we're below 0. So although the value we associate with that 0.4 is 0.2533, it means that U is negative 0.2533. And to find the value of V, for which Z is greater than V, has a 2.5% chance. 2.5% is the same as 0.025. So the value of Z that corresponds to that is 1.9600. This time, however, we are on the right-hand side of the mean, the right-hand side of the graph, so the value will stay as a positive number. So the answer is 1.96. So in summary, because U has to be left of the mean, that means that Z has to be negative, and because V has to be right of the mean, that means that Z will be a positive value. Okay, in a minute we're going to have a look at a worded example, but a quick note about the Z distribution, if we want to convert it into the X distribution for all different normal distributions. So Z is defined as a normal distribution with a mean of 0 and a standard deviation and variance of 1. If we wish to convert any value from a normal distribution X to Z, then we use the formula X minus mu all divided by sigma, i.e. X minus the mean divided by the standard deviation equals Z. So we're going to look at one example with words to put this into context. The masses of cauliflowers in a Fate large vegetable contest are modelled by a normal distribution with a mean of 650 grams and a standard deviation of 70 grams. And we've been asked to find the minimum mass of the heaviest 2.5% and the maximum mass of the lightest 40%. So let's start off finding the minimum mass of the heaviest 2.5%. Let's call that M1. So we've got a normal distribution with a mean of 650 and a standard deviation of 70, and we want the probability that X is greater than M1 to be 2.5%, i.e. 0.025. Now we've already found that the Z value that corresponds to that is 1.96, and then applying the formula that turns X into Z values, we have M1 take away 650 all divided by 70 equals 1.96, from which we can rearrange that and get a minimum mass of 787.2 grams. And then for the maximum mass of the lightest 40%, again we've already looked at the Z value that corresponds to, and that is negative 0.2533. So we want the probability of X being less than M2, where M2 is this maximum mass, to be 0.4, and hence we want M2 minus 650 over 70 to be equal to this Z value of negative 0.2533, from which, again rearranging, we get 632.3 grams.